we are talking about page 553. We are going to problem solve. Use tangents to solve problems. That's the right way to say it. By the way, this is a reminder that we are talking about tangent, cotangent. We're talking about trig ratios that solve for unknown side lengths. We're using, well, we're not doing this one yet, but we are going to apply trigonometric ratios and use the Pythagorean theorem to solve real world problems. So that is the important concept for us to be thinking about as we answer these questions. You've used Pythagorean theorem to solve for unknown side lengths and right triangles given two of the sides. Do you remember what the Pythagorean theorem is? How to apply it? Go back and practice if you don't. Here's the Pythagorean theorem. And if I may, this is the highlight scheme that I would apply to the Pythagorean theorem. Opposite, adjacent, and hypotenuse. Right? Our color scheme from highlighting the sides and angles of a triangle. Consider the proposed wheelchair ramp. And this is what they call in the industry a callback. So on page 549, we had this example about what safe minimum specs are for wheelchair ramps, that the ratio should not exceed 1 to 12. So that's what I want to write right here. The ratio of the vertical rise to the horizontal run must not exceed 1 to 12, which would be like 1 foot of rise to 12 feet of run. 1 inch of rise to 12 inches of run, but that's not necessarily useful information. You were talking like if the wheelchair just take off and take the person unsafely with it, this is at maximum the safe rate or steepness of the wheelchair slope. Write a decimal that represents the greatest value of the slope of a safe ramp. So I'm going to take that 1 to 12 ratio and write it as a fraction. 1 over 12. Hey Siri, what's 1 divided by 12? Remember, fractions mean decimal. 0.08333. So approximately 0.08333. Any ratio that is bigger than 0.08333 is a ratio of the opposite side to the adjacent side, and it is too great of a ratio. It's too large of a ratio to really be useful, like safe, okay? So use technology to calculate the value of tangent of 4 degrees. Again, we would say tan 4, but we should say tangent, the whole word, tangent of 4 degrees. That's how we should repeat that. And I'm going to write that here. Tangent of 4 degrees equals, approximately equals, but let's do the yellow calculator now. And so if you have a school-approved calculator, bring that into place. If you don't remember how to do the calculation, go watch one of my previous videos. I'm going to do tangent of 4. And I get 0.069927. Approximately 0.06997. If that number was greater than 0.08, we would have a problem. 0.069927 is less than the 1 to 12 relationship. So therefore, yes, we have a safe ramp. Yes, this is our ramp is safe. Okay, and we may proceed with the construction. Otherwise, the inspector comes in, says, you're not operating a safe environment, you must shut it down. Okay, we need to know the run of the proposed ramp. And so the run is the distance along the x line. It's the adjacent side. But because we have tangent of an angle, we can write tangent as a ratio. So the top of the tangent ratio is the opposite side. Tangent is opposite to adjacent. So I can write the 2 feet as the top of my fraction. I'm going to use the apostrophe for now. And then the adjacent side is the run, and it's on the bottom. And it's going to be x feet, so that I'm knowing what sort of like measurements to communicate to our builders. Now, tangent of 4 is that decimal. And you can either use tangent of 4, because we know what it is, or we can use its decimal equivalent. But the point is, right now, we cross multiply. So x times tangent 4. I use the dot right here to represent, let me slide the camera a bit better into view. I use the dot to represent multiply, and I should be using parentheses around my angles. So go back and fix them. Put parentheses around the angle if you don't. The calculator does. We certainly should. The calculator also doesn't use a degree symbol because it needs to be in degree mode. So we're checking that as well. On the other side, it's 1 times 2. I've also dropped the feet. Technically, the feet markers, they reduce each other out, so they're gone. Okay. It's not solved, though, because we got rid of the fraction, but we haven't made x be the only thing on its own side of the equation. So one more step to do, and that's to divide. You can tell red was step number 1, right? And blue is step number 2. Step number 2, divide both sides by the tangent of 4 degrees. Tangent of 4 degrees. And it's totally okay to do this because it's solving an equation. And when we solve equations, you can divide by the division property of equality, provided the number is not 0, and it'll allow us to reduce this side of the equation, leaving us with a single solitary x equals, that's the adjacent side. And go to your calculator. 2 divided by tangent of 4 degrees. I've already got tangent of 4 calculated here, so I just got to do this. 2 divided by the answer. Answer, control, and then that minus, that negative symbol. So that's going to allow me to use that number right there. And when I go enter, 28.6013 feet. Approximately 28.6013 feet. There you have it. Maybe a question to consider. What does this 1/12 mean that makes the ramp safe? How does 1 foot of rise to 12 feet of run give us a good estimation that we have a safe ramp for wheelchair travel? And then last of all, the height of 24 inches is not used in this fraction. But what if we did? What if we didn't convert back up here the 24 into the 2? How would that maybe change this answer? Would our answer still be valid? What would you communicate to the architect or to the construction manager that tells us about how the ramp would need to be constructed? Solving real-world problems with tangent is a good skill to have. Thank you for watching page 553. 554 is next. Here's a sneak peek. We're going to continue to practice what we need to do to figure out how to use tangent or cotangent to solve real-world problems. See you in the next episode.